and welcome to our presentation titled Leveraging Twitter Data to Analyze the Virality of COVID-19 Tweets. My name is Krishna Das, and I'm the Associate Professor at Middlesex University, Dubai. I'm joined by my wonderful colleague and co-author, Geetu Joy, and both of us have worked on this interesting project, which is very apt in the given context of the COVID-19 pandemic. Next. Let's look at what is happening today. This is not a surprise. In fact, the word COVID-19 sends out jitters to several people in the community today. It has taken the world by the storm. And it is no surprise that it is changing almost every aspect of our life that we have thought about. In fact, some people say that COVID-19 has transformed the definition of the word uncertainty because it seems like a never-ending, uncertain process. The world is fighting on two different fronts, the economic front and the biological front, where at one end, the race is to figure out how to make a better economic situation. And at the other end, the race is to find out a cure and develop a vaccine from the biological front. In this whole context, in this whole race, which is redefining the way we look at things, the way we work, it is absolutely important to develop some fresh ideas and perspectives that could not only be applicable for a pandemic like this, but any other uncertain events that occur in the future. Next. With the COVID-19 situation, we all would agree that the social media and the online world has drastically changed. In fact, some of the figures on your screen right now, if you look at the percentage increase, this was in April 2020. So if you look at October, November 2020, it would be way too much more. Significantly, a lot of people have increased watching news coverage, spending their time on social media, working on work-related tools because everything is work from home. People are significantly watching more films and shows and spending more and more time on mobile, internet, and online world. Next. Given this sort of a situation, we wanted to identify something really interesting. So we wanted to look at how things have changed when it comes to communication over social media. So we all would agree that pre-COVID-19, the things that were cool, the things that were shared, the things that were liked and commented are not pretty much the same things that are happening now. Moreover, if you look at the social media platform like Twitter, for example, there was a report that said that COVID-19 related tweets are being retweeted every 45 milliseconds, which shows the importance of the content that is pouring into the world of social media. This brings up a lot of research questions as to how things have changed, how communication has changed, how sharing of information has changed, and what are the factors that leads to sharing of content which is related to social media. So our main motivation was to look at the change in not only human behavior, but also the online social media behavior when it comes to situation like COVID-19. And in general, we wanted to explore the communication on social media in a disaster situation, in an emergency situation like COVID-19. So we did some research first in order to look at the available studies, and then we formulated our research design to address a very interesting research question as to what are the factors that affect the sharing of content on Twitter in particular. I'll now invite Geetu Joy, my co-author and colleague, to continue with the rest of the paper. Geetu, stage is all yours.
Thank you, Krishnadas. I'm Geetu Joy. I'm a faculty with Middlesex University, Dubai. So before we go into the conceptual framework, I would like to brief on the existing literature on social media content and virality. So as per a paper that was published in 2009 by Kashmir, the factors that affect virality of a content are completely random. But however, on further research, we identified several studies that have conducted research on the dimensions of a viral content. According to Heath et al. In 2001, the emotional aspects of a social media content plays an important role in deciding its virality. Esser and Huberman in 2010 tried to study the prediction power of social media. They identified that the rate at which tweets are created on a particular topic can act as a predictor of future events, and it more often could outperform the real world predictors. Berger and Milkman in 2012 suggested that any positive content has a high probability of being viral than a negative content. They also suggested that contents that evoke high psychological arousal have a higher chance of being viral. In 2020, Tellis et al. Conducted a study on virality of YouTube ads. The authors suggested that contents with positive emotions, brand prominence, and information content had a higher chance of being viral. Mayerhofer tried to understand the virality of contents on Facebook. User-generated content, however, created higher purchase intention in comparison to advertisements and brand posts, according to authors of the study. Twitter, as we know, is one of the most popular platforms for information dissemination. We had several research works from the literature that backed this claim, and one of the main reasons was the information diffusion potential of Twitter due to the inclusion of URL and hashtags. Wang and Yang in 2020 tried to understand the role played by Twitter in an organization. They tried to create a content analysis of tweets an organization has posted on its Twitter page and understood that the organization's dialogic communication was highly influenced and the public engagement increased greatly. In 2020, Roy et al. Tried to identify the influence of social media during the Hurricane Sandy. They tried to evaluate the social media effectiveness in communicating information during a crisis. They identified that the retweet of a content depends on the number of followers and friends, user category, bot score, and the activity patterns. We all know about the influence of Twitter on election. We found few interesting studies. Salmanos et al. In 2020 tried to identify the role of state-sponsored trolls in influencing the US presidential election. In their study, they found out that 4 out of 1,000 profiles and 1 in the top 100 were only trolls. The remaining were all from authentic users, which suggested that the driving force behind influencing the US presidential elections was actually authentic users or authentic profiles. Bright et al., however, concluded that using Twitter as a broadcasting mechanism does not help gain any edge in electoral outcomes. Now, looking into the factors that affect the virality of tweets pre-COVID, the role of hashtags in virality was studied in detail by Scasa and Gleis. Mendoza, however, was concerned about identifying fake news from authentic news. They analyzed the information on Twitter activity related to 2010 earthquake in Chile. They suggested that doing an aggregate analysis on the tweets will help identify fake news from rumors. Coming to the intersection of social media and COVID-19, we went through several research work where the authors had mentioned how social media was acting as a platform of information dissemination. As we all know, with the ubiquitous nature of social media, the pandemic soon spiraled into an infodemic. One of the trending hashtags in 2020, and even now, is the coronavirus hashtag. Several authors suggested how social media has become a conduit for spreading misinformation and even spreading panic among its users, even much more faster than the coronavirus itself. Emphasized in their research, Larson and Macaulay, how the social media is now playing a major role in spreading fear and panic among its users. Now, identifying a fake news from an authentic news is one of the major challenges during the pandemic. Regarding that, we had Penny Cook et al. The authors suggested that nudging the users to evaluate a news accuracy before sharing is one of the ways of preventing a fake news from spreading. Gao et al. Suggested that government must identify measures to combat the infodemic while trying to combat the citizens' mental health problems that arose as part of COVID pandemics, such as depression and anxiety. Merchant and Lurie suggested creating a framework that integrates online platforms as a major tool in remodeling aspects of readiness and creating precautionary actions for the future. For example, they pointed out that the Facebook newsfeed now works by redirecting users clicking on the COVID-19 link to authentic websites such as the WHO website or the local health authority websites. From the literature review, we identified that a lot of the work was based on how information went viral pre COVID. But what are the factors that influence the virality of a content during the COVID-19 phase? Hence, we looked into the factors that could affect, and from the literature review, as we have seen already, people generally share content on social media for the usefulness of the information, sometimes for initiating a conversation, for updating an information, or for maintenance of social relationships. It was interesting to find out that Fur et al. Suggested that sharing content was viewed as an aspect that could generate mutual benefit for both the users who share and for the consumers who consume the content online. As per our understanding from the literature, we decided to focus on the role of emotion focused post in COVID 19 sharing. As we see, content with positive emotions had a higher chance of being shared, according to God's et al. The influence of positive valence on content sharing was also covered in several research papers. Berger and Milkman hypothesized that the virality of a positive content could be explained by using the viral content theory. They suggested that a post that has emotions, negative emotions or positive emotions, could also lead to higher sharing. The psychological arousal evoked by these emotions also affect the sharing, according to Smith and Ellsworth from their study in 1985. What happens as part of these emotions or arousal is that it leads to potential actions such as assisting others. And in the context of COVID 19, this meant sharing information that the reader or the user felt is authentic. So, as we can see, balance, arousal, or emotions play a major role in content sharing in pre COVID. When it comes to the COVID stage, we could explain this further by using the inside out perspective by Nanath Grover. During the pandemic, emotions or contents that were initially frowned upon are now encouraged. For example, contents regarding mental health, anxiety, depression. These were encouraged, these are currently encouraged, unlike the pre COVID phase. This could be further explained by using the theory of resonance, which is suggested by McDonald et al. The author suggested that a user generally shares a content that resonates with their views or emotions when they read the content. Hence, we deduce that emotions, whether positive or negative, play a major role in COVID 19 sharing. Hence, the hypothesis, we created 8 hypotheses, which are tweets evoking anger, anticipation, disgust, fear, joy, sadness, surprise, and trust will have more retweets in the context of COVID 19 content. Looking at the role of information focused content in COVID 19 sharing. What is an information rich content? Any content which includes factual description about people, location, organization, and events is an information rich content. Pre COVID, an information rich content was not generally preferred by users. The actual possibility of such a content being shared was very less, one of the major reasons being the lack of altruistic motives. However, during the COVID 19 phase, this has changed. This can be explained by using the language expectancy theory suggested by Berger and Miller. Information driven content is expected during a crisis. Users need factual information, up to date information, and unambiguous information. And this comes with the suggestion of creating tweets with more mention of names, locations, and organizations. Hence, we deduce in the hypothesis that tweets with these attributes will have more retweets in the context of COVID-19 content. What about the role of tweets and linguistic features? The influence of tweets' content features such as hashtags, URLs, and user mentions, and the contextual features such as a number of followers was studied by So et al. In 2010. Zarella also studied the influence of linguistic, psychological, and timing features along with the above mentioned contextual features and content features. The motivation behind using hashtags was studied by Rochenobel, and he suggested that different users create hashtags based on the motivation behind. Diffusion of information during crisis via Twitter and influence of content features was again studied by Son et al. In 2019. The author suggested that any tweets that contain essential or trending hashtags helped in much higher information retrieval during a crisis, and in our case, COVID-19. L. Potts et al. Identified the role played by tweet features in retweet during crisis. The author suggested that length of a tweet and hashtags positively influences a retweet. They also suggested that usage of several hashtags or overusage of hashtags or creating user mentions can negatively influence a retweet. In essence, retweet count is influenced negatively by the usage of overusage of hashtags or user mentions. Twitter has a word count of 140 characters, and hence using too many hashtags can hinder information processing. User mentions are generally used in Twitter to create more interaction or increase profile visibility. However, according to Tang et al., during a crisis, users prefer more generic content than content that is meant for a specific group of users. Lee and Yu in 2020 concluded that information rich content is preferred during crisis. And by information rich content, they suggested a content that is rich in language or has more information that can be used by the public. And with the context of COVID 19, this could be pandemic related guidelines or medical information. And hence, we deduce that any content that has higher number of words with respect to tweets, an increase has higher or has a positive influence on the retweet count. An increase in the number of hashtags in a tweet, however, had a negative influence according to our hypothesis. And usage of popular hashtags in a tweet can increase the retweet count. The fourth hypothesis in this section was that an increase in the number of user mentions can negatively impact your retweet count. Based on these factors, we created a conceptual model which contributed towards emotion-focused content, information-focused content, and on linguistic features. Coming to the research methodology, we took tweets from the Twitter for a time period of 29 March to 29 April, and for this we used the Twitter API and the R-tweet package CRAN. To ensure fairness in retweet count of the tweets, we extracted the information during a common time window of 15 minutes, and at the end, we combined all the information that we had collected from 29 March to 29 April using the Azure Machine Learning Studio or the AML Studio. We decided to keep the retweet count as a critical variable, and by removing missing values, invalid data points, inappropriate variables, we created a clean data set which had 57,331 tweets. To ensure that repetition is avoided, we removed retweets and maintained only the original tweets. Of course, the language filter we used was for English. This is a framework that we used for our research methodology. As you can see, we used data cleaning and created a data set of 57,331 tweets, followed by which we conducted pre-processing again by using Microsoft Azure Machine Learning. In this step, we remove stop words, remove punctuations, normalize the words from uppercase to lowercase, remove double characters, and so on. This helped us to ensure that we have a clean data set for the NLP. Extracting emotions from a clean data set was done by using the zero-shape package in R, and the results were 8 different emotions. Named entity recognition of tweets was again run by using Microsoft Azure Machine Learning, and the results we had the information of people, location, and organizations that were mentioned in the tweets. Linguistic features were extracted by using the tool Python, in which we extracted the number of words and hashtags present in a tweet. To create a list of popular hashtags, we set a threshold of 750, and any tweet that had hashtags with an occurrence of greater than 750 was classified as a popular hashtag. We also extracted the user mention information by using the tool Python. The idea was to run linear regression on the hypothesis and to create predictions. However, depending on a study from the literature, we identified that it is also useful if you could identify the topics that were tweeted during the COVID-19. And for this, we used the LDA algorithm, and we ran this by using the AML. Generally, Azure Machine Learning creates 2 outputs. It creates a feature topic metrics, and it creates a topic loading for each tweet. So we segregated these topics based on the topic feature metrics, and then we identified 5 different topics. According to literature, 5 number of topic was the optimal number of value, although we tried different topic values from 5 to 30. We stick to 5 different topics, and the topics were home isolation or stay at home, which was topic 1. Topic 2 was more about hygiene and sanitization. Topic 3 was about government and policies. Topic 4 was about mental health, and topic 5 was about optimism and solution. So at the end, we had a combination of several variables, 21 variables to be precise. And in this, we decided to use something called as a mixed effect linear regression model. According to literature, this is one of the models that is being used for social media content analysis and sharing. We took the log of retweet count because the retweet count from the original data set was not normally distributed. Hence, we took the log transform and we regressed this over the 21 independent variables. We had 8 emotions, 5 topics, 3 topics from NER, which was name, location, and organization, and 4 linguistic features. We used 2 control variables, the follower count, which would account for the heterogeneity in the profile, because certain profiles had more followers and the retweet count was more higher for such accounts. So we use follower counts to account for the heterogeneity in profile popularity. We also used a tweet level random intercept to account for any unobserved heterogeneity that we may not have included as part of our variables. At the end, the variables were checked for multicollinearity with VIF. Coming to the results and discussion, we received a conditional R square of 14.8%, and we also were able to identify a few of the hypotheses as true and some as false. Coming to the emotion focused content, we had 8 different hypotheses in this session. According to our theory, according to our test and the results, negative emotions or contents having negative emotions such as anger, disgust, fear, sadness, and surprise has a higher probability of being shared. And hence, we confirm the hypothesis A to G. Tweets with negative emotions had higher resharing. This could further be explained by using the inside out perspective. Positive emotions, however, anticipation, joy, and trust, did not turn out to be significant predictors of the tweet. Hence, hypothesis H1B, 1E, and 1H were not supported, or tweets with positive emotions had a negative impact. This could be explained by using the outside-in perspective. Regarding the information content, information-focused content, we had formulated 3 different hypotheses: people, organization, and location. If these information are present in your content or in your tweet, it had a higher chance of being reshared under high-risk conditions. And in our case, this was COVID-19. And we received full support for this hypothesis from our testing. Linguistic features, we had concentrated on 4 different features: word tweets or length of a tweet, number of hashtags present, presence of popular hashtags, and mentions. According to our hypothesis, 2 variables had a very positive and significant impact, and this is the number of tweets and the presence of popular hashtags, which means any COVID tweet which had higher number of words and the presence of popular hashtags had a higher chance of being retweeted. According to our hypothesis, any tweet that had more number of hashtags or user mentions had a lower chance of being retweeted, and we got full support for this particular hypothesis from our results. Hence, hypothesis 1 received partial support, hypothesis 2 and 3 received full support. The topics that we had included as part of topic modeling, again, we had 5 topics, in which topic number 4, which was mental health, and topic number 5, which is optimization and optimism and solution, had a very positive and significant impact on the retweet count. Optimistic tweets such as hashtags, we are in this together, we can do this, were found to have a higher probability of being shared. Tweets on mental health were also tweeted for wider reach and mental support. This table describes an explanation of each of the variables that we had included, the coefficients and the p-values that we obtained at the end of the result, at the end of after running our linear regression model or the mixed effects model. Now, regarding the theoretical and practical implementations or implications of this study, the results that we received could be used for the officials and the individuals who intend to use social media platforms to disseminate COVID-19 related information. As per our literature, Merchant and Laurie had suggested that we could use online platforms to spread information regarding COVID-19. Hence, this could be used by officials and individuals who intend to use social media platforms to disseminate such information. Research findings could also encourage the practitioners or volunteers or organizations to focus on linguistic style cues and emotions for effective communication on social media. The information-focused content had a very high impact and a significant impact on the retweet count, because this offers a clear perspective to the content creators, which will give the idea that they should reduce the uncertainty in the content that they post by including more named locations and organization names, which will help increase the virality of the tweet because it looks more authentic to the users. The results also suggested that negative emotions play a very important role in content sharing, as users understand that these emotions during COVID-19 and are willing to share them for a wider reach and for better social support. The theoretical contribution of the study, of course, is twofold. The literature review, all the works were around thematic content analysis or the use manual coding procedures. In our paper, we used machine learning algorithms, which helped us to automate this coding. So this approach could be used in several other natural language processing applications where they could overcome the disadvantages of manual coding. The research also incorporates the significance of crisis timings. This was a major insight that we received that the sharing behavior of individuals changed during a crisis. What was initially encouraged is now discouraged, and what was initially discouraged pre COVID is now being encouraged. However, the limitations were that we were concentrating on one of the pandemics, that is COVID-19. Generalizing the results to a broader context of risky and more critical conditions could be a little difficult. And added to that, we used tweets from one social media platform. There are several other social media platforms, and they have different rules for posting the content, and hence the behavior sharing could also differ. In the future, we would like to extend this current research by using multiple social media platforms and incorporating various pandemic stages. Also, we would like to include various locations as this could also change the content sharing behavior in general. So that's it from us. Any questions?